Assalamualaikum warahmatullahi wabarakatuh. So today we are going to learn about load characteristics from chapter 1, Basic Electrical Power System. So the load is varying from time to time. Actually, we can obtain the load profiles by plotting the power demand in watt or kilowatt or megawatt against time in hours. So when we plot from 24 hours of a day, it is called daily load curve. And if the time considered for 1 year, it is called annual load curve. So the area under the curve represents the energy generated in the period consideration, which is in watt hour or kilowatt hour or megawatt hour. And the area under the curve divided by the total numbers of hours will give the average load on the power plants. Average load. And the peak load indicated by the load curve represents the maximum demand on the power plant. Thus, the load factor can be obtained from the load curve as the ratio of average load over a design period to the peak load occurring in that period. So we get the load factor equal to the average load divided by the maximum load or the peak load. And we know that the average load is equal to the energy generated in the period consideration. So we get the load factor equal to the energy generated in the period consideration divided by the maximum demand or peak load. Okay, so the load factor may be daily or annual load factor based on the period consideration, which is whether a day or a year. So for daily load factor, the T will be equal to 24 hours. So we call it daily load factor. And for annual load factor, the T is equal to 8,760 hours. So we call it annual load factor. Okay, for capacity factor, it is equal to the average power divided by the plant capacity. So we know that the average power is equal to the energy generated in T hours divided by T hours. So that means the capacity factor is equal to energy generated in T hours divided by the plant capacity multiplied with T hours. So for annual capacity factor, so we get the formula, the annual plant capacity factor equal to the annual energy output divided by the plant capacity multiplied with 8,760 hours. So this is the hour for 1 year. Okay, different to plant use factor. Plant use factor is energy generated in T hours divided by the plant capacity multiplied with T hours in service. For example, in 1 year, the plant operation in 300 days. So that means the T will be equal to 300 multiplied with 24 hours, which is 7,200 hours. So that is the difference between the plant capacity factor and the plant use factor. Now look at example 1. The daily load of a substation is given in this table. So based on the given data, calculate the average load, P average, and calculate the daily load factor. Okay, so the question asks you to find the average load and the load factor based from this table. And we know that the load factor is equal to P average divided by P max. Okay, so first we need to calculate the average load, and we know that the average load is equal to the energy generated in the T period consideration divided by the total numbers of hours. So in our case, the T is equal to 24 hours and the energy generated is the area under the curve. So this will give Here, for example, from 12 to 2 a.m. is the time interval is 2 hours, multiply with 400, plus, for example, from 2 a.m. to 6 a.m. the time interval is 4 hours, multiply with 300 megawatt, and so on. So this is the energy generated under the curve, divide by 24 hours, so we get the average load equal to 1062 megawatt. Okay, and the daily load factor is equal to average load, P average divided by P max, and the P max here is 1800, so we get the daily load factor 1062 megawatt divided by 1800 megawatt, so we get 59.03%. Okay, example 2, the daily load on a power system varies as shown in table 1. So plot the daily load curve, calculate average load and daily load factor. Okay, so we know that the daily load curve can be plotted for 24 hours time frame. Okay, so we plot the daily load curve for power against time. From 12 to 2, the load is 6 megawatt. From 2 a.m. to 6 a.m., the load is 5 megawatt. And then from 6 a.m. to 9 a.m., the load is 10 megawatt, and so on. So actually the area under this curve, under this load curve, is the energy generated in that period. To calculate average load, we know that the area under this curve divided by the total number of hours will give the average load on the power plant, so that we can calculate the average load as sum of energy in T hours divided by T, which is equal to 24 hours. So we get the average load as 11.5417 megawatt. To calculate the load factor is equal to the average load divided by the maximum load. So the maximum load here is 18 megawatt. So we get the load factor equal to 64.12%. Now look at example number 3. A power station has two 60 megawatt units, each running for 7,500 hours in a year, and one unit of 30 megawatt power plants running for 5,500 hours in a year. The energy produced per year is 750 times 10 to the power of 6 kilowatt hour. Determine the plant load factor, calculate plant capacity factor, and calculate the plant use factor. Assume the maximum demand to be 80% of the plant capacity. Okay, now the solution. The capacity of the power plant, we have two power plant with the size of 6 megawatt and one power plant with the size of 30 megawatt. So the total capacity of the power plant is 2 times 60 plus 30 megawatt, which is equal to 150 megawatt. And the maximum demand is 80% from the plant capacity. So 80% from 150 megawatt is equal to 120 megawatt. So this is the peak load or the maximum demand. So to calculate the load factor, we know that the load factor is equal to the energy generated in T hours divided by the P max multiplied with T hours. So in this case, this is annual load factor. So the T is equal to 8,760 hours. The maximum demand is 120 megawatt, and the energy generated in T hours is given as 750 times 10 to the power of 6 kilowatt hour. So the load factor is equal to 71.3%. So the plant capacity factor is equal to energy generated in T hours divided by the plant capacity multiplied with total numbers of hours. So in our case, the T is equal to 1860 hours, which is annual. capacity factor, and the plant capacity, which we have calculated earlier, which is equal to 150 megawatt, and the energy generated is given as 750 times 10 to the power of 6 kilowatt hour. So we get the plant capacity factor equal to 0.57. The plant use factor is equal to the energy output in kWh divided by the plant capacity multiplied with the total hours in service. So the energy that can be generated by two 60 megawatt units power plant and one 30 megawatt power plant is equal to 2 units multiplied with 60 megawatt multiplied with 7,500 hours, because the 60 megawatt power plant is running for 7,500 hours. And then the 30 megawatt power plant is running for 4,500 hours. So the energy that can be generated is equal to this value. And the plant use factor is equal to the actual energy generated divided by the energy that can be generated. Okay, or we can straightforward use this formula so that we can see that the T hours now is equivalent to the hour the power plant is in service. Okay, so the value for use factor is equal to 0.72. Now look at example 4. A power plant had a maximum load of 20 megawatt and the units generated or the energy generated is 61.5 times 10 to the power of 6 kilowatt hour for a year. Calculate the load factor. So the load factor can be calculated by using this formula. So the energy generated is 61.5 times 10 to the power of 6 kilowatt hour. And then the maximum demand or maximum load is 20 megawatt. And the T is equal to 8,760 hours for 1 year. So the load factor is equal to 0.351 or 35.1%.